Solubility and equilibrium. In this video, I'm going to be discussing the dissolved ions of a salt in water and how that's related to equilibrium. We're going to be talking about these solutions in the three basic conditions we consider solutions. Unsaturated, when there's less solute than the solvent can hold. Again, you can imagine a glass of water here. And this is where we've put just a little bit of salt into the water and it dissolves fully. We could even put more salt in this water and it would continue to dissolve. We'll consider the saturated situation. This is where the solvent is holding the maximum amount of solute it can hold, which means if you add another spoon of salt to that cup of water, it won't dissolve, but it's just going to sit as crystals at the bottom of the cup. And finally, the supersaturated situation, where we've played some sort of trick where we've either maybe increased the temperature of this liquid or something so it'll hold more solute for a temporary point of time, and then we've reduced it, and now, at least in this temporary situation, the solvent is holding more of the salt or more of the solute than it should be able to. When we consider that, then we can look at the dissolving process of the salt. Typically, when considering it from an equilibrium perspective, we write the forward reaction for the salt, regardless of what's happening, as the solid salt dissolving into its two ions, its two aqueous ions. Oops, I don't know what that happened there, but that's okay. Bring that back. So, sodium chloride dissolving into sodium ion and chlorine ion will be considered the forward reaction. And remember, even below the saturation point, the reverse reaction happens. So if we imagine we have a liquid, and we have our ions, and this is an undissolved crystal, it's all in the same location. Then slowly over time, the ions will detach from the crystal and spread out in the solute, and they'll be surrounded by the water molecules. The negative ions will be surrounded by the partially positive hydrogens, and the positive ions will be surrounded by the partially negative oxygens. And it'll dissolve until this whole crystal goes away, and all we end up with is ions spread evenly throughout the solution. That doesn't mean that the reverse reaction doesn't happen. That doesn't mean that just because an ion leaves, it can't possibly come back and rejoin the crystal. But what it does mean is that the rate of ions leaving the crystal is greater than the rate of ions joining the crystal, all the way until the crystal becomes fully dissolved. What that means then is that at some point at the end, there's no crystal remaining for the ions to go back to, and as a result, there's no equilibrium. The backwards reaction actually stops. The backwards reaction actually stops because there's no crystal for this to go back to. There's no solid for it to join back onto. So that's the unsaturated situation. Both occur, the forward and backwards reaction, but more ions leave than come back, and more ions go into solution, and eventually there's no crystal left, so then there's nowhere to go back to, and the reaction stops. Now let's look at the saturated solution situation. Here, what we're saying is we've added so much salt to this liquid that for a period of time, some of it dissolved, some minuses went into solution and some pluses went into solution, and that kept happening and happening and happening. And what happened is as the concentration of ions in the solution built up, the rate at which ions leaving the solution happened became equal to the rate at which ions rejoined the crystal. What that means then is the number of ions in solution became constant. Also, the salt appeared to stop dissolving. Now we know that this is a dynamic equilibrium. The ions keep leaving and other ions keep coming in to replace them, but because the rate of ions leaving, or what we call the forward reaction, becomes equal to the rate of ions rejoining the crystal forward rate and backward rate are equal, and so the saturated situation is the equilibrium. Finally, the supersaturated situation. Now, here, maybe we've heated up this water or something, and we've gotten way more ions than should be able to dissolve into this solute, or solvent, sorry. So there's lots and lots of salt dissolved, more than should be able to. Sometimes this system can be fairly stable. If there's no crystal for these ions to attach to, it can be very difficult for them to get a crystal started themselves. But they will eventually do that, get a crystal started themselves, or if you want to speed up this process, you can add a little seed crystal to this solution. Because the concentration of ions in solution is so high, the rate at which they join the crystal will be very fast. In fact, it will be faster than the rate at which they leave the crystal. What this means is then the crystal will grow or get larger. And it will continue to grow and get larger until the concentration of ions in solution goes down to the saturation point. So here, if we have this, we're saying that these concentrations are too high, so they will lower, or the reaction will proceed this way until we get more NaCl. The amount of undissolved crystal in the solution doesn't really matter. The fact that there is an undissolved crystal in solution is important for the ions to have a place to go and attach to, but once it's there, it doesn't really matter all that much how big it is. So, as these NaCl's go and attach to the crystal at a faster rate than they're leaving, the crystal grows, but more importantly, the population of these two things gets depleted, and it goes from being the supersaturated situation to coming down to just the saturated situation. And then we'll recall that at the saturated situation, the rate of ions leaving the crystal and joining the crystal becomes equal, and as a result, the size of the crystal becomes constant. It stops growing and it stops shrinking. So, below equilibrium or below saturation, we have more ions leaving crystal than coming into crystal, to the point where the crystal officially disappears and all the ions just exist as ions in the solution. At saturation, sorry about that. So until you have enough crystal that there's enough crystal to support the rate of the ions leaving the crystal being the same as coming back. And if you start above that saturation point, then you can imagine... Okay, again, sorry for the interruption. So if you start with a supersaturated solution, you have too many dissolved ions in your solution, so you're past the equilibrium point. So the rate of the crystal growing, or the rate of the backwards reaction, is greater, reducing the concentration of the dissolved ions, getting you back again to your equilibrium or your saturated situation. So that's just a brief overview of those terms and how they relate to equilibrium.